Children, today we are going to learn about VSEPR theory, valence shell electron pair theory. Already we have learned Lewis concept. In Lewis concept, we have learned the molecule structure based upon the lone pairs. But today, according to VSEPR theory, it predicts the shape of the molecules. So, before going to predict the shape of the molecules, we have to learn some important principles regarding this VSEPR theory. So, one by one, we are going to see the principles. Number one, the shape of the molecule, whether it is a linear, trigonal, bipyramidal, octahedral, tetrahedral, square planar, many shapes are there. So, the shape of the molecule first depends upon the number of valence shell electron pairs around the central atom. What is valence shell? Valence shell means the outermost shell. Consider this is an atom. There are many shells. This is the outermost shell. This is not involved, only the outermost shell, the last shell, that is called valence shell. So, the shape of the molecule depends on the number of valence electron pair around the central atom. Second principle, there are two types of electron pairs. One is bond pair, the other one is lone pair. What is bond pair? What is lone pair? Bond pair means shared between two atoms. Lone pair means that are not involved in bonding. For example, take water molecule H2O. Here O is the center atom, two hydrogen atoms surrounding the hydrogen. Here oxygen, the atomic number 8, valence electron is 6, 2, 6. So among the 6 electron, 1 will be here, 1 will be here, 2, remaining 4, 1 pair and another pair. Hydrogen atomic number 1, so only 1 electron, 1 electron, so a bond is formed here. So a bond consists of 2 electrons, 1 belong to hydrogen, 1 belong to oxygen. So 1 electron involved in bonding. Here also 1 bond, 2 electrons, 1 belong to hydrogen, 1 belong to oxygen. Then these two pairs are kept lonely. They are not involved in bonding. Such bonds are called as lone pair. These are bond pairs. Usually, the lone pairs are said to be delocalized. Delocalized means they are free to move. They are not tightly closed. So they are called as delocalized. Delocalized. But the bond pair which is involved in bonding held between the two atoms tightly packed. So it is localized. It is localized. So this lone pair, even for example, you see oxygen, hydrogen, hydrogen, the electron cloud between the bond pair will be like this. The shape won't change, but in lone pair it expands like this. It gets expand, that is called delocalized. This is as it is because it is tightly held between the two bonds, cannot expand, not even able to move. So it is localized, this is delocalized. So lone pair, this is bond pair, bond pair. Lone pair, 2 electrons means 1 pair, lone pair, bond pair, bond pair. So usually there is here the repulsive force at the main part. Repulsive force. What is repulsive force? The electrons both having equal charge, so they get repelled when they are close to each other. There is lone pair repulsion, lone pair repulsion, bond pair repulsion. This is lone pair, there is repulsion. lone pair bond pair repulsion, bond pair repulsion. Three type of repulsions are there. Lone pair repulsion, lone pair repulsion, bond pair repulsion. This is decreases like this order. This is the highest, then goes on decreasing. Now, these pairs of electrons which is around the central atom repulse each other, and hence they are since to minimize the repulsion, the electron pairs are located as far as possible in some distance apart in three-dimensional space to minimize the repulsion between them. Then the fourth one, the repulsive interaction between different type of electrons, that is lone pair, bond pair. So there are four principles. The four principles given clearly in book page number 81. So based upon that, to explain the VSEPR theory, we have to keep in our mind, to predict the shape, we have to keep in our mind, that is central atom is involved, which is kept in the middle. Then depending upon the valence electrons, then there are electron pairs, two type of electron pairs, bond pair and lone pair. This and all we have to keep in our mind. If we are taking central atom, consider as A, it should be a single atom, not should be paired. Similarly, it should be a bigger molecule, then it should be a less electronegative atom about the single atom, central atom. Then the bonded atoms, the atom bonding with the central atom, that is kept as B. Then the lone pair of electron. These three are important: central atom, bonded atom, lone pair. Based upon that, there are many divisions. See, AB2, central atom, bonded atom, AB2 type, AB3 type, AB4, AB5, AB6, AB7. Now with the lone pair, AB2L, AB3L, AB4L, AB5L, then AB2L2, AB3L2, AB4L2, AB2L3. Likewise, many classifications are there. Based upon that, one formula we have to learn to easily understand the shape of the molecule. Steric number formula, this you have to by heart. Half into number of valence electrons in central atom plus number of single bond plus or minus charge. This formula, it's not given in a book, but for easy understanding of the shape of the molecule, this formula you thoroughly by heart. Steric number is equal to half into number of valence electrons plus number of single bond plus minus charge. So based upon this shapes, if the steric number is 2, hybridization is sp, shape linear. If it is 3, the hybridization is sp2, the shape is trigonal planar. If the steric number is 4, hybridization is sp3, shape is tetrahedral. If it is 5, hybridization is sp3d, trigonal bipyramidal. If the steric number is 6, hybridization is sp3d2, the shape is octahedral. The next video part, we are going to learn the shapes of the molecule predicted by VSEPR theory based upon the steric number formula, and we are going to draw the structures.